Okay, let's move to our next question. Our next question is a calculus one. They've given us this figure. Let's see what this figure represents, and we're going to underline. The figure above shows a design of a theater stage, which is in the shape of a semicircle. Okay, so we know that is R. Semicircle means it's a half circle, okay, which is attached to a rectangle. Now with that information, if this is a rectangle, we know that these are perpendicular, that length is 2R, and that this length over here will indeed be B. Opposite sides are equal to each other in a rectangle. The semicircle has a radius of R, thank you, they've given it to us, and the rectangle has a breadth of B. The perimeter, so the perimeter of the stage is 60 meters. Now folks, the perimeter is if you walk across the walls or the edges of this stage, that is your perimeter. So that line in the middle of the stage is not part of the perimeter. Okay, so let's see. If we have our perimeter here, the perimeter will be 2Bs plus, so it's this side, this 2R, which is at the back, and then here we have the circumference of the circle. Now we know that a circle has an area, first of all, of pi r squared, and it has a circumference of 2 pi r. Okay, so if we had a full circle. In this case, we have a half circle, so we must times each of these by a half. So this circular part here will be pi r. Now that collectively gives you 60. Okay, so we can play around with it. Let's see what they ask us to do. They say find B in terms of R. Okay, we're already busy with that. So we're busy answering the first part for 2 marks. If I get B by itself, I get 2B is equal to the 60 minus 2R minus pi r, and then I divide by 2. So finally, B will equal 30 minus r, it's 60 divided by 2, minus 2 divided by r, and then minus pi over 2r is what remains if I divide that by 2. Okay, so there's the first part of the question done. Okay, let's see what they ask us now for 6 marks. They ask us to find the value of the radius so that the area of the stage is a maximum. So now we need the area of this stage, which consists of a rectangle and a circle. Okay, so let's go for that immediately. The area of this stage is going to be length times breadth is usually for the formula for the area of a rectangle. So it's 2BR. It's that multiplied the 2R multiplied by B. And here we have half a circle, which is pi r squared. Now this B over there, folks, I'm going to substitute what I have over there in the place of B. So I get 2R multiplied by that B, which is 30 minus R minus pi over 2R is 2BR plus pi r squared. Okay, now I can clean this up. I can multiply this out. So this gives us 60R. The 2R times that gives us minus 2R squared. The 2R multiplied by minus pi over 2R is minus pi r squared. Check yourself. It's a r times an r, which gives you r squared. The 2's cancel, so you have minus pi r squared plus pi r squared, so that component disappears completely. Okay, so what are we left with? We're left with our area in terms of r, which is 60r minus 2r squared. Now what do they ask us? They ask us for the maximum area. To find the maximum of this area of this stage, we use calculus. We now have to differentiate this and solve it equal to 0 because that gives you your optimum value. Okay, so we go into phase 2. I'm going to change color. Therefore, now we say A prime r is 0. If I differentiate, I get 60 minus 4r, which is 0. So what is 4r? Don't forget your therefore signs. 4r is indeed 60. And then what is that value of r? R will be 60 divided by 4, which is indeed 15 meters.